In the late summer of 1977, two unmanned spacecraft, Voyager 1 and 2, lifted off from Cape Canaveral atop Titan Centaur rockets. Traveling uninterrupted through interstellar space, the Voyagers will endure forever, long after everything man has ever built has crumbled into dust. In the event the spacecraft encounter alien intelligence, both Voyagers carry a copper phonograph record, a message, celebrating the sights and sounds of Earth.
And friendly wishes.
These unique discs contain photographs of everyday life, as well as voices, offering greetings in 55 languages. There are also animal noises, the music of Beethoven and Chuck Berry, a baby crying, laughter, rain, and a heartbeat. All of the planets in Voyager's path were in perfect alignment, something that occurs only once every 176 years. The spacecraft were in position to visit all 4 of the outer planets. In March of 1979, nearly 2 years after launch, the Voyagers approached Jupiter, the celestial body that so fascinated Earth's first modern astronomer, Galileo. Passing through the boundary where the supersonic solar wind slams into Jupiter's magnetic field, the spacecraft's instruments recorded a strong bow shock. Named after Jove, the supreme god of Roman mythology, Jupiter is an enormous whirling sphere of turbulent gases, big enough to hold over 1,300 Earths. The Voyagers discovered thin rings of dust encircling the planet, tiny grains containing silicon or carbon, like a fine haze of ash and smoke. Jupiter's atmosphere displays a dazzling variety of alternating patterns. Cold, light-colored zones dominated by ammonia ice crystals in the higher altitudes, and warmer, dark belts of solid sulfurous particles in the lower altitudes. Voyager's cameras afforded scientists spectacular close-up views of the Great Red Spot, a storm 3 times the diameter of Earth raging in Jupiter's atmosphere. Voyager atmospheric scientist Dr. Andrew Ingersoll.
The Great Red Spot is a counterclockwise rotating storm, sort of like a hurricane, that has persisted for over 3 centuries. We were amazed that this spot could survive in the midst of all this turbulent activity.
With at least 16 known moons, Jupiter could well be considered a mini solar system. The Voyagers flew by the 4 largest, finding Callisto pockmarked by craters, Ganymede etched by icy parallel grooves, Europa smooth and icy, and Io glowing a cold and sulfurous red-orange. 9 active volcanoes were found on Io, the first observation of live volcanoes beyond Earth and Venus. These geysers were spewing hot, sulfurous gases 100 miles, high enough to hit a passing satellite. Voyager project scientist Dr. Edward Stone.
If I were to pick one discovery to represent the body of discoveries that Voyagers made, I would pick the discovery of the volcanoes on Io. These were totally unexpected and really forced us to reconsider our whole concept of the evolution of small moons which are orbiting in the outer solar system.
Pulling away from Jupiter after a joint reconnaissance of more than 6 months, the Voyagers got a healthy boost from Jupiter's orbit and made a beeline for Saturn. Mystifying man since the dawn of history, Saturn bears the name of the mythological god of the harvest, who reigned in the Golden Age. Traveling at more than 55,000 miles per hour, Voyager 1 arrived in November of 1980, only 12 miles off course after an interplanetary journey of more than 1 billion miles. Voyager's instruments found Saturn's atmosphere to be a cold ball of hydrogen and helium gases, racked by huge whirling storms and whipped by winds of up to 1,100 miles per hour. Saturn's magnificent rings, thought to have been the result of collisions between earlier moons and asteroids, consist of thousands of particles, swirling pieces of rock and ice, streaked like the grooves in a phonograph record. Voyager atmospheric scientist Dr. Andrew Ingersoll.
What Voyager discovered was the incredible structure in the rings. Saturn's rings are really composed of countless numbers of particles, ranging from the size of dust and perhaps larger particles the size of houses. These particles are constantly bumping into each other. These grooves are there because the rings are constantly being disturbed by satellites orbiting in with the smaller ring particles themselves.
As the Voyagers swept by, sunlight penetrated, backlighting and brilliantly illuminating the splendor of the rings, like the spokes of a gigantic Catherine wheel. Voyager 1 flew within 2,500 miles of the surface of Saturn's largest moon, Titan. One of only 3 moons in the solar system known to have an atmosphere, Titan may help unlock secrets to the origins of life. Voyager project scientist Dr. Edward Stone.
Certainly one of the more exciting discoveries at Saturn was the atmosphere of Titan. It's an atmosphere which is mainly nitrogen like that here on Earth, but which contains methane, so that the photochemistry going on there today may resemble very strongly that which occurred here on Earth billions of years ago before life evolved.
By swinging around Saturn, after a close-up view of Titan, Voyager 1 was propelled out of the plane of the solar system and is now traveling toward interstellar space. First detected in 1781 by English astronomer Sir William Herschel, Uranus, in Greek mythology, is the name for the heavens. 5 years and almost 1 billion miles after leaving Saturn, Voyager 2 reached Uranus in January of 1986. Like all the other planets, Uranus spins like a top, but tipped over on its side. Strangely tilted and off-center, Uranus's magnetic field extends in a bizarre corkscrew tail millions of miles into space. Its magnetic poles are also wildly askew. Voyager 2 discovered 2 new rings. Dark, narrow, thin bands of ice, rock, and dust with particles the size of a fist. Although Voyager 2 discovered 10 new Uranian moons, the most eagerly anticipated event was the close encounter with Miranda, one of the most bizarre moons in our solar system. Close-ups of Miranda revealed a strange and wondrous landscape, including a canyon 12 miles deep. Miranda may have collided with another moon, shattered, and then by the force of its own gravity slowly reassembled itself into this chunk of rock and ice. These digitized photographs are a silent testament to the violent origins of our solar system. After 12 years on the road and another 1 billion miles, Voyager 2 was an exhausted traveler. By August of 1989, Voyager 2 was speeding more than 40,000 miles per hour toward its rendezvous with Neptune, the last stop on its spectacular grand tour of the 4 outer planets. Discovered in 1846, Neptune was named after the mythical Roman god of the sea. The planet appears blue because its methane absorbs most of the red in the spectrum, leaving mostly green and blue. Voyager 2 flew by Neptune only 22 miles off its charted course, and only 1 second off its scheduled flyby time. Skimming only 3,000 miles over the planet's north pole, Voyager found Neptune to be a giant ball of melted rock and ice, cloaked in hydrogen, helium, and methane gases, its atmosphere whipped by winds of up to 700 miles per hour. Voyager flew the closest that any spacecraft has come to one of the outer planets, discovering at least 4 complete rings of ice and rock, 6 new moons, and a great dark spot, a hurricane the size of Earth raging in Neptune's southern hemisphere. Dr. Andrew Ingersoll.
The storm revolves around the planet every 18 hours, and then it rotates around its own axis like a big glob of pizza dough every 16 days.
Largest of Neptune's 8 moons, Triton orbits in an opposite rotation from the planet. Triton was once probably an independent object in orbit around the Sun, until it collided with a moon and was captured by Neptune's gravity. Pockmarked by impact craters and glazed pink by a radiation blitz of methane and nitrogen ices and atmosphere, Triton is the coldest known object in the solar system and one of the most reflective. Utilizing Voyager's digitized photographs of this icy moon, scientists saw jagged mountains, high cliffs, and frozen lakes. The most bizarre discovery on Triton was the presence of icy geysers, some of which are still active, spewing organic particles 100 miles downwind. Dr. Edward Stone.
The Voyager mission to the outer planets has certainly been a journey of a lifetime. Having encountered Triton as the last world we would visit, I don't see how any of the scientists could have been happier.
Voyager 2 has set its course for southwest of the constellation Sagittarius. Traveling at 10 miles per second, it is expected to pass 4 light years from Sirius, the brightest star in the heavens, 290,000 years from now.
At 70 times further from the Sun than the Earth, Voyager 1 is at the very edge of the solar system. The Sun there is only 1/5,000th as bright as it is here at Earth. For 25 years, the Pioneer 10 spacecraft led the way in pressing the frontiers of our realm of exploration. And in a certain sense, what's happening is the baton is being passed from Pioneer 10 to Voyager 1, which now has to take up pressing this frontier, going where no one has been before. The two spacecraft, Voyager 1 and Pioneer, are actually headed almost opposite directions away from the Sun. Pioneer 10 is headed down what's called the tail of the heliosphere, the comet-like shaped region that forms around the Sun, while Voyager 1 is headed toward the nose of the heliosphere.
The latest data from Voyager 1 indicate that we are clearly in a new region where things are changing quickly, says Ed Stone, Voyager project scientist at the California Institute of Technology in Pasadena. This is very exciting. We are approaching the solar system's final frontier. The frontier he's referring to is the edge of the heliosphere, a great magnetic bubble that surrounds the Sun and planets. The heliosphere is the Sun's own magnetic field, inflated to gargantuan proportions by the solar wind. Inside lies the solar system, home. Outside lies interstellar space, where no spacecraft has gone before. A telltale sign of the frontier's approach is the number of cosmic rays hitting Voyager 1. Cosmic rays are high-energy particles such as protons and helium nuclei, accelerated to near-light speed by distant supernovae and black holes. The heliosphere protects the solar system from these subatomic bullets, deflecting and slowing many of them before they can reach the inner planets. As Voyager approaches the frontier, the number of cosmic rays has gone up. From January 2009 to January 2012, there had been a gradual increase of about 25% in the amount of galactic cosmic rays Voyager was encountering, says Stone. More recently, however, we have seen a very rapid escalation in that part of the energy spectrum. Beginning on May 7, 2012, the cosmic ray hits have increased 5% in a week and 9% in a month. The sharp increase means that Voyager 1 could be on the verge of a breakthrough 18 billion kilometers from Earth. When Voyager 1 actually exits the heliosphere, researchers expect to see other changes as well. For one thing, energetic particles from the Sun will become scarce as the spacecraft leaves the heliosphere behind. Also, the magnetic field around Voyager 1 will change direction, from that of the Sun's magnetic field to that of the new and unexplored magnetism of interstellar space. So far, neither of these things has happened. Nevertheless, the sudden increase in cosmic rays suggests it won't be long. Meanwhile, Voyager 2 is making its own dash for the stars, but because of its slower pace, lags a few billion kilometers behind Voyager 1. Both spacecraft remain in good health.